Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. If you really like my teaching and my efforts, please press the like button, share the videos with your friends, subscribe to my channel, and also press the bell button to get the regular updates. In this video, I want to discuss about exclusive NOR. Okay, already we have discussed about exclusive OR and its properties. Similarly, I have discussed about NAND and NOR also. Now we will see what the exclusive NOR. Let's take that I have taken the two Boolean variables A and B. If they are Boolean variables, then I will get the four combinations such as 0, 0, 0, 1, 1, 0 and 1, 1. Now how to represent the exclusive NOR? Exclusive NOR can be represented as this way. Am I right or wrong? Now what is the exclusive NOR will produce the output? How I can expand the exclusive NOR is equal to A, B or A complement and B complement. This I can expand. Exclusive NOR I can expand like this. Now substitute the A value and B value as 0 and 0. What it produce? Okay. What it produce? Now if you see that 0 and 0 are 0's complement and 0's complement, which is equal to 0 and 0 is 0. 0's complement is 1. Again 0's complement is 1. So 1 and 1 will produce 1. So 0 or 1 is equal to finally it produce value as 1. So when A value is 0, B value is 0, exclusive NOR is producing the output as 1. Now if you want to verify, when the A value and B value is 1, it also produces the output as 1. If you want to verify, you can verify. A value is 1, B value is 1. So 1 and 1 is equal to 1. Now A complement, 1's complement is 0. Now B's complement, B value is 1, 1's complement is 0. So 0 and 0. So 0 and 0 is equal to 0. So 1 or 0, you will get 1. Is it clear? So here also you are getting 1. When A value is 0, B value is 1, you will get the output as 0. If you want to verify, you can verify it also. A value is 0, B value is 1. Now if you see that, if I substitute A value is 0 here and B value 1 or A's complement, 0's complement will be 1 and B's complement, meaning is that 1's complement which is 0. So totally you will get 0. Is it clear? Even here also you will get. How I got this one, how I simplified? I have simplified this expression and substituted the value, I got it. Is it clear? Or some people will say that you already know exclusive OR, complement of exclusive OR, you will get exclusive NOR. Am I right or wrong? Is it clear? So, now come to this properties. First basic property is the idempotency. What is the idempotency? Says that A exclusive NOR A should be equal to A. If it is so, then I will say that exclusive NOR is satisfying the idempotency property. Now we will expand this left hand side equation. I will get it as A and A or A complement and A complement, which is equal to A and A, which is equal to A. Will you accept with me or not? A complement and A complement will give the A complement. Now if you see that A or A's complement will give the value as 1. If you want the proof, I can give you. A value is 0 or 1. A's complement will be 1, 0. What is complement? Whenever input is 0, the output will give the 1. Is it clear? Whenever the input is 1, output will give the 0. Now take the A or A's complement. Now which is equal to 0 or 1. Which is equal to what? 1 and 1. What is OR gate property? If any one of the input is 1, the output will be 1. So if you see that this function A or A's complement is always producing the output as 1. So I can write it as 1. So left hand side I got the 1. Right hand side I have A. Now can you tell me whether left hand side is equal to right hand side? I can say that left hand side is not equal to right hand side. So it is not satisfying the idempotency property. Now we will see whether it will satisfy the commutative property or not. Okay. What is commutative property? A exclusive NOR B should be equal to B exclusive NOR A. Is it clear? Even you can prove this one using the truth table, or you can simplify this equation also, you can do it. I will discuss both the ways so that you will understand the concept in a better way. So what I will do is that I will simplify the left hand side. If I simplify it, I will get it as AB or A's complement and B's complement. See, whenever I am saying AB, meaning is that A and B. Is it clear? Now this is equal to, if I expand the right hand side equation, then I will get BA or B's complement and A's complement. Now whether left hand side is equal to right hand side? Yes. You have here AB, here you have BA. Both are same only. And A complement, B complement, here also you have. I can say that left hand side is equal to right hand side. So I can say that exclusive NOR is satisfying the commutative property. If you want, with the help of truth table also, I can prove it. Okay, already we have computed the output for the function A exclusive NOR B. Now we will compute the B exclusive NOR A. What is the exclusive NOR equation? I can say that whenever both the inputs are same, here A value is 0, B value is 0, A value is 1, B value is 1. Whenever the A value and B value are same, or both the inputs are same, it produces the output as 1. That is what it was proved in the earlier function, A exclusive NOR B. So similarly, if B exclusive NOR A also will produce the output as 1. If both the inputs are not same, it produces the output as 0. Is it clear? So I can say that this function A exclusive NOR B is producing the output as 1, 0, 0, 1. Similarly, this function B exclusive NOR A is also producing 1, 0, 0, 1. So I can say that these two functions are equal and they are satisfying the commutative property. Okay. Now we will check whether it is satisfying the associative property or not. What is the associative property? A, B, C. Okay, you take the exclusive NOR over the right associative should be equal to left associative. Left associative means A exclusive NOR B over exclusive NOR C. Now what I will do is that I will substitute one of the equation, means I can do the truth table, I can keep the A value, B value, C value. I will get 8 combinations and I will find the output for this function, output for this function. If they are equal, I can say that these two are equal. Otherwise, what the simple process? I will keep any one of the value, either A value as 1 or 0. Let me keep it A value is 1. Then what will happen if one of the variable, if I keep 1, I can reduce this equation in the 3 variables to 2 variables. Am I right or wrong? With 2 variables, I can satisfy, or I can say that whether the LHS is equal to RHS or not. Are you able to understand it or not? Now we will see. If I substitute the A value is 1 in the LHS, what will happen? 1 exclusive NOR B exclusive NOR C. Is it clear? Are you able to understand? Is equal to 1 exclusive NOR B exclusive NOR C. Are you able to understand it or not? Now, what I can do? I can write or I can simplify this equation as 1 and B exclusive or C or 0 because A is complementary. What is this one? A exclusive nor B can be written as AB exclusive AB or A complement and B complement. Here what is the A value? A value is 1, B value is this one. So what I have done? A and B, then A's complement, 1's complement will be 0, then whole this complement. Now if you see that, what I can write? 1 and with anything, then I will get the anything only. So here 1 and B exclusive or C, I can write it as B exclusive not C, plus 0 and anything will be 0. So finally I can write it as B exclusive nor C. So this entire equation I simplified it as B exclusive nor C. So I can erase this part. So I can say that LHS equation I simplified when I keep the A value as 1 as B exclusive nor C. Now it should be equal to RHS. What is the RHS is there? 1 exclusive nor B. Simplify this equation, 1 and B are 1 complement B complement. 1 and B is B. 1's complement is 0 and B's complement. 0 and B's complement will be 0. B or 0 is equal to B. So this one if I simplify, I got the value as B. B exclusive or C because I have left the exclusive or. Now if you see that LHS is saying that B exclusive nor C is equal to right hand side is also saying B exclusive nor C. So LHS is equal to RHS. Then I can say that these two are equal. If you want the proof, even when A is equal to 0 also you can check it. What will happen? Is it clear? When A value is equal to 0, what will happen? Because lot of people have doubts, sir. Last few examples when you are discussing about NAND, NOR and exclusive OR, you have taken A value is 0. But when it comes to exclusive NOR, you kept the A value is 1. So it is a cheating. So to make you happy, I will even solve when A is equal to 0 also. Okay. If A value is 0, 0 exclusive NOR B exclusive NOR C is equal to 0 exclusive NOR B exclusive NOR C. Now this can be written as 0 and B exclusive or C or 0's complement which will be 1, B exclusive NOR C whole complement. Am I right or wrong? I have considered this as A and this is B. So A and B are A's complement and B's complement. So 0 and something you will get 0 or 1 and something you will get the same thing. B exclusive nor C. Is it clear? Which I can, let me write it. So I can say that this is equal to B exclusive nor C whole complement. Now come to the right hand side. Right hand side is 0 exclusive nor B. I can write it as 0 and B or 0's complement and B's complement. Is it clear? So this is 0 or B's complement. I will get the B's complement. Are you able to understand it or not? So I got the B's complement exclusive nor C. Now simplify these two equations. What you will get? This is nothing but if I apply the De Morgan's law, this will be B exclusive or C is equal to, oh sorry, how I can write this one? This is exclusive NOR. So this will be equal to B complement C whole, B complement and C complement, which is equal to B complement and C or B C complement. Now you expand the left hand side. B exclusive or C. B exclusive or C can be written as B C complement or B complement C. Now tell me whether LHS is equal to right hand side or not. Means LHS is equal to RHS or not. You have B C complement. Here also you have B C complement. Similarly here you have B complement C. Here also you have the B complement C. So you are performing addition between them. Obviously you will get the same value. Suppose let's take that this is 2 and this is 5. So I can write it as 2 is equal 2 plus 5. If it is 5 or 2, then meaning is that both will be 7. So I can say that these two equations are same. Then what I can say? It is associative. Are you able to understand? Is it clear? I hope you have understood how I solved this question. If you still have any doubts related to this question or this property exclusive NOR, feel free to ask me in the comment section. I will try to clear your doubts in less than 24 hours. Thank you for watching my video. Have a nice day.